Okay, let's move on to example 2. So let's look at the question. We have use the substitution u equals 1 plus e to the power x to show that e of 3x over 1 plus e of x dx is equal to half e2x minus ex plus ln 1 plus ex plus a constant k. So this is a shown question. We need to prove that right hand side. So we need to start off by writing out our question. So we're going to start off with integration of e 3x over 1 plus ex dx, and we have our substitution. Now our substitution is u equals 1 plus ex. And like before, that would be the best place to start. Now remember, we have to prove that right hand side. So when you're doing a question like this, don't get too worried about that right hand side now. Ignore it. Let's deal with the question, and in time we will prove that question. Okay, so u equals 1 plus e to the power x. So we're going to differentiate that with respect to x. So we have du dx equals, and you know that differentiation of ex is simply ex again. We can, like before, make du the subject. So we're going to have du equals ex dx. The problem we've got now is that the numerator is e to the power 3x. We have an ex dx. So somehow we need to get this ex dx and make up something else to make up e3x. And here it makes sense for us to say integration, and instead of us writing e3x, we could write e2x times by ex dx. Now if you just look at this carefully, that times together would make e to the power 3x, just like we have in the question, over 1 plus ex. Okay, so let me write that again. So at the moment we have e 2x multiplied by ex dx over 1 plus ex. Well, we know that du was equal to e dx. So in this case, this is going to be du. We know that 1 plus ex from the question is u. So now we need to think about how we manipulate e2x. So let's do one step at a time. So we've got integration of e2x. Let's get the u out of the way here. So ex dx from earlier was du over u. So the issue now is that e2x must be changed in terms of u before we move on. Okay, so what do we have so far? We know that u equals 1 plus ex. So could we not then say that ex is equal to u minus 1? So e2x must be the square of u take 1 whole squared. And that's where we're going to continue from. So we know that u equals 1 plus ex. e2x is equal to u minus 1 whole squared. If we expand u minus 1 whole squared, we get u squared minus 2u add 1. So putting that all together in our previous integration, we have integration of u squared take 2u add 1. I'll put that in brackets. Then multiplied by the du that we had earlier over u. Let's just focus here. Now we've removed all elements of x. All we have is expressions involving u, and we have to do that with respect to u. So this is now ready to integrate. So what we're going to do now, we're going to split these up by dividing every element here by u, and we're going to end up with integration. U squared over u is simply u. 2u over u is 2. Add 1 over u, we can leave as 1 over u du. So we have, from our last line, u minus 2, add 1 over u du. So let's integrate. Integration of u is going to be u squared over 2 minus integration of 2 is 2u plus ln u. We're then going to convert that back by changing the u into the appropriate substitute. So we now have 1 plus ex squared over 2 minus 2, open bracket, 1 plus ex plus ln of 1 plus ex, and don't forget we have a constant c. Now that on its own quite messy, so we need to try and get the right hand side. So the best thing to do now is to expand the brackets. Okay, so it's going to be our next line. Okay, so we have got expansion of 1 plus ex whole squared. We'll have 1 plus 2ex plus, now ex times ex, don't write ex squared, common mistake, is e2x over 2 minus 2 times 1 is 2, minus and a plus is a minus 2 ex plus, you can't expand that, so we write it as ln 1 plus e to the power x, and keep bringing that constant c. So from our last line, we had 1 plus 2ex plus e2x all over 2 minus 2 minus 2ex plus ln 1 plus ex plus c. We're going to split this 1 over 2, 2ex over 2, e2x over 2. So we're going to have half plus e to x plus half e to x minus 2 minus 2ex plus ln 1 plus ex plus rc. So now look at trying to collect like terms. So let's slow down for a bit. We have got a half there. We've got a minus 2. we have an EX there and a minus 2EX there. So we can at least condense that. Now half minus 2 is minus 3 over 2. We have EX minus 2EX, which will naturally give us minus EX, plus half E2X plus ln, 1 plus EX plus our C. Now let's just stop for a bit. Let's just look at the proof that we need to try and get. If you look at the question and look at the right-hand side, we know we're in the right track because we've got a half E2X, that's there, and we've also got the ln 1 plus EX. We've also got the minus EX there. So all we need to think about is our constant. So we're actually nearly there. If you think about this, we have got minus 3 over 2, but we've also got a constant that goes part of the answer. So in this case, your K isn't just minus 3 over 2. It's minus 3 over 2 with the plus C. So it's minus 3 over 2, add the C, and those two together make up our K. And that is what we end up with in our answer. Thank you for joining us. Again, please leave any comments in the sections below. Don't forget, give this video a thumbs up. Hope you enjoyed it. And if you haven't done so already, please subscribe to the channel and remember to share this with your friends and family. Thank you very much, and I'll speak to you soon. Bye-bye.